Hello students, in today's session we will talk about the equality of two population means as the first case for two population inferences. So what we need to consider the behavior of the data or the underlying patterns involving the data. The data may be approximately normally distributed but may be approximately symmetrical. And normality tests that we usually apply to test the normality of behavior of the data set can be applied over here in this case. And the results of KS and SW test will tell us whether the given data are approximately normal or not. So if the two data sets that we are dealing with are independent samples or dependent samples. Independent samples we call the two data sets when at the time of collecting data we divide the total number of respondents or total number of subjects into two different categories, and one group of individuals is treated with one type of treatment and another group of people is treated with another type of treatment, or two different strategies or two different plans are applied to two different groups that are divided already. So one group that experience one type of treatment does not experience another type of treatment. Or the second group that experience some type of treatment, the first group is not getting any exposure to that particular type of treatment or behavior or experiment. So the way we collect the data, we call it independent samples. Independent samples, the total number of subjects are not divided into two groups before applying two different experiments. So all individuals, all subjects that are included in the group go through both the type of treatments or both the types of experiments. So in that case, we apply or use dependent sample approach. So in case of independent samples approach, when data follows approx normal behavior and the samples are independent samples, then we have two choices to make between. Either we go for pool T approach or non-pool T, depending upon whether the population variances related to the different data sets are indicating the equality of two population variances or standard deviations, or inequality of two population variances or standard deviations. So if the two population standard deviations or variances are found equal, then we go for pool T. If found unequal, then we go for non-pool T. Similarly, if the data sets are approximately normally distributed, but the approach that we follow to collect the data is dependent samples approach, then we need to go for paired T approach. Similarly, in case of approximately symmetrical behavior when two data sets follow, then in that case, we need to again identify whether the given case is the case of independent samples or the dependent sample. If this is the case of independent samples, we have a choice to apply or use Mann-Whitney equality of mean or equality of median test. In that case, that can simply we call it as M-test. Similarly, if we are given the case of dependent samples as far as data collection is concerned, then we apply or use paired W test or paired Wilcoxon sign rank test. This is how we classify or explore five different varieties of kinds of tests that are applicable to test the equality of two population means or two population median in case of a non-parametric test. So let's start with the independent samples case, and the data file I have already imported in SPSS. In this data file, we have considered gender and their wages. So the data are already coded for gender. The data are coded as one is indicating male, two is indicating female. Whereas wages are quantitative, therefore there is no need to go for any coding for the wages. Now first of all, we will examine this data file for normality. So we are going to perform normality test, and that's analyze, descriptive, explore. Since we are dealing with two groups, so we need to analyze the behavior of normality or non-normality on the basis of gender here. So we take wages in the dependent list and we take gender as a factorless variable. After moving these two variables in their designated positions or areas, we click on plots, we mark a check across none, we mark a check across normality plots with test, continue, and then paste. We now select this entire selection and then perform this test, and we look at the outcome of the normality test. And this is what we have repeatedly done in the past or already in case of one population as well. So over here we have to look at the two results. Both Kolmogorov-Smirnov and Shapiro-Wilk tests indicates that male, both the wages of male and female are approximately normally distributed. So I'm again going to write down H0 and H1 for this, for these two groups. So normality test we are performing for the two groups where we can write down as H0 in H1 wages of male and female follow normal distribution or normally distributed, whatever you like to state it as. And wages of male and female do not follow normal distribution. As usual, we mention the level of significance at which we usually perform the test. That is 0.05 we use as a yardstick. Test statistic are 2, that's Kolmogorov-Smirnov and Shapiro-Wilk. And decision rule or criterion we write down as usual following the words as the condition under which H0 would be rejected. So H0 would be rejected if p-value associated with Ks or SW statistic is less than 0.05. Now we can write down the decision and conclusion is looking at the results that we got in the table, both the p-values for male and female and for both Kolmogorov-Smirnov and Shapiro-Wilk test are exceeding 0.05. Since p-values associated with both Ks and SW is statistic for male and female groups for their wages or regarding their wages are not less than 0.05. Therefore, H naught is not rejected and it cannot be concluded that the wages of male and female workers do not follow normal distribution. So data do not support non-normality argument here in this case. And since the cases are independent samples, because male data is separated from female data set regarding their wages, therefore the samples are independent samples and we can go for either a pool T or a non-pool T test. And for this, again we need to perform the equality of variance test at the first place, because we can decide about the application of pool T or non-pool T application. For the equality of mean testing, we need to know whether the population standard deviations are proved equal or unequal. Therefore, we first go for equality of variance test and then we go for equality of mean testing. So let's suppose we would like to perform it as a left tail test or a right tail test, and we can in fact inquire this right there in advance after looking at the relationship between the standard deviations of the two groups. So what we do, we again look at the output table where we have performed normality test, and here we can see that standard deviation of wages of male workers is 20.262, where the standard deviation of female is 18.546. So that's less. In fact, we can perform a right tail test to examine that this excess in standard deviation or variances of male as compared to female workers can be generalized or not for the entire population. So that's we are relying upon the inference for that. Here, level of significance is 0.05. Test statistic is Levene's test we applied for the equality of variances or standard deviations, and we write down the decision criterion as usual, what we have written down already in the previous question. H naught would be rejected if p value associated with Levene's statistic is less than 0.05. Now we are going to perform this test, and this is analyze. We go for then compare means, then independent samples t-test should be our option. Then wages we need to take as the test variable. Gender we need to take as a grouping variable. So when we enter this gender as a grouping variable here, two question marks will appear, and we will now define the two groups with the values with which we have coded these two groups. So group 1, which is male, has been coded with 1 and female with 2. Now we paste this. We go to syntax file. We select this syntax. Then we run this test, and this is how we get the results. So this is independent sample test result, in fact consolidated for both pool T and non-pool T, because as you can read easily, the two assumptions written next to wages, for the first row the assumption is equal variance is assumed, and for the second row it is mentioned as equal variance is not assumed. So this is the first two columns that gives us Levene's test for equality of variance result. So f is very small relatively, and the significance associated with f is 0.518. That is leading us to go for non-rejection for H naught. So what we do, as far as the decision criterion we have mentioned or discussed over here, it says H naught would be rejected if p value is less than 0.05 and p value is not less than 0.05. So we write it down accordingly. So decision and conclusion. We state as since p value associated with Levene's statistic is not less than 0.05, therefore H naught is not rejected. and it cannot be concluded that standard deviation of wages of male workers exceeds than that of female workers. This is how we perform equality of variance test. Now, as the next step, we can now go for performing equality of mean test, which is pool T most probably because equality of variance test is not rejected. So H naught for a pool T test for equality of mean is mu1 equals mu2. H1 is mu1 not equal to mu2. We are performing it as a two-tailed test. So level of significance, if we are given 0.05, we need to divide alpha by 2. That gives us 0.025 as the significance level allocated or assigned to both the tail end regions equally. Then test statistic is pool T that has this formula x1 bar minus x2 bar minus mu1 minus mu2 divided by SP times, which is the pool standard deviation SP represents, it multiplied by the square root of 1 upon n1 plus 1 upon n2. Now we write down our decision criterion, same as before. Now in terms of pool T statistic, obviously, if for H naught will be rejected, if p value associated with pool T statistic we have to look at is less than 0.05. Now we look at the results of pool T that's given in the first row of this table. So we look at the significance, which is no 0.861, and this is not less than 0.05, therefore H naught would not be rejected. And we write down our decision and conclusion as H naught since p value associated with pool T statistic is not less than 0.05. Therefore, H naught is not rejected and it cannot be concluded that the mean wages of male and female differ significantly. So, this is how we perform pool T procedure. Now, I'm going to apply non-pool T procedure on the same data file just to guide you that in what condition you are going to use non-pool T procedure. At the first place, if we were observing the rejection of equality of variance test in favor of the alternative hypothesis that we have stated over here, so in that case, we should have the p-value in this table corresponding to Levine statistic should be less than 0.05. So assume that this value is less than 0.05. If that's the case, then this would lead us to go for the rejection of H naught for equality of variance or standard deviation. So if equality of variance is rejected in favor of alternative hypothesis here in this case, then we write down our write-up for the findings accordingly. Here, decision conclusion we will be writing down as since p-value associated with Levene's statistic is less than 0.05 in that case, therefore H naught is rejected and it can be concluded that the standard deviation of wages of male workers exceeds than that of female. Consequently, due to the rejection of equality of variance test, we are now bound to go for non-pool T procedure, which is given in the second row of this table. So again, the steps that we follow for non-pool T procedure is same as a H naught we write down same way, H1 we write down same way, second step we write down same way. But the formula for non-pool T procedure is this. Numerator in both no pool T and non-pool T remains same, but from denominator we delete out this SP factor because we are not going to pool the standard deviation or variance. Therefore, we leave the different variances, sample variances in the inside the square root sign as this. So this is the formula for non-pool T procedure, and this is the formula for pool T. So that's the difference in approaches. And as far as decision criterion is concerned, we will write down the decision criterion in the same way, just replacing this pool T statistic word with non-pool T statistic. Similarly, if we observe rejection or non-rejection, whatever it is, usually the results of pool T and non-pool T are not greatly different for a given data, even though when it is the equality of variance test rejection or non-rejection, but the results of pool T and non-pool T are different do not differ significantly. So equal variance is not assumed is a row we will select, and we will read out this probability corresponding to non-pool T procedure or non-pool T statistic, and we write down our decision in the same way. So this is how we perform independent sample t-test using polarity and non-polarity approach. That's all for this.